Okay, on 24 here, this is just another question about bringing meaning to this really useful and special function, the reciprocal function. At this point, you should be able to graph that reciprocal function, or at least sketch the graph. And we know that this reciprocal function has asymptotes. It's kind of these invisible lines that the graph gets closer and closer to but never touches. That's what the definition of an asymptote is. And as these two branches, this reciprocal function, one branch looks like this, and one branch looks like this. So if we do a little deeper investigation, it says, do all these points appear? Let's check it out. So 1/3, if we put 1/3 into the reciprocal function, we get 1 over 1/3. If we clear those fractions by multiplying by 3 over 3, we get 3 over 1 equals 3. So that point is on there. And then, if we did one more, f of 20, that just gives us 1/20th. Well, there, that's already simplified, so 20 gave us 1/20th. You can see that these are all flips, which makes sense because this is the reciprocal function. So yes, all these points appear. And they're all related because they're actually reciprocal pairs. So that's the idea here, is if you can think of any possible reciprocal, those points will be on this graph. So let's just find these here. 1/3 and 3 is maybe about right here. Call that 1/3 and 3. 20 over and 1/20th is way out here because I got to go over to input of 20. 1/20th. -1 and 1 is right here. If you can think of any reciprocal, that'll be on this graph. Like if we took pi and reciprocal 1 over pi, that'll be on this graph. Pi is about 3.14, and so that number here would be 1 over pi. Sorry, that point would be pi 1 over pi. E, 1 over e, would also be in this graph. So a little review for exponentials, but e is like that 2.71 ... 1 over that is some number. Well, you'd find that on this graph as well. That'd be like right there. That'd be e, 1 over e. So that's what this reciprocal function means. Any possible reciprocal you could ever think of has to appear on this graph somewhere. And that's what this graph is doing for you. Okay, for this sketching reciprocal graph transformations, let's, like I did for the prior unit, let's just remind ourselves what that looks like. If we have a parent function f of x equals 1 over x, the transformed version of that will look like this, and all those terms will have the meaning that they've had all year. So we'd have a over x minus h plus k. And you need to remember where these pieces go, but they all have the same meaning. A is going to be the vertical stretch factor, like the stretch Armstrong idea, stretch or compress. If a is less than 0, then it's a reflection. That also happens there. H is going to be the horizontal shift, and k is going to be the vertical shift. And if this is positive vertical shift, it's going to be up. Negative will be down. Positive here will be right. Negative will be left. I won't do all of these, I'm going to just do 2 of them, but you'll get the idea. And so the way that the step-by-step process we've done for these reciprocal function transformations is, first, is to see what's going to happen to the asymptote pair. So just remember that that parent function, I'll draw that up here, has asymptotes at y equals 0 and x equals 0, and the graph looks like this. I think the first thing is to understand what happens to this. These asymptotes are going to shift by the vertical shift. So I'm going to go ahead and do b. So let's identify what the parameters are for b here. B, a is just going to be 1. H is going to be -2. Don't forget, we have to think about that x minus 2 to get x plus 2. k, there's an implied 0 here, so k is 0. So this is going to mean left 2 and no vertical shift. Well, the parent function had asymptotes here, so let's find where they're going to be under a shifted condition. So we have to move to the left 2. So this vertical asymptote is going to move to the left. This other one is not going to move. So this is now going to be kind of the center of our graph. -2, 0, right there. And then, so that orients us. Now we have to kind of thread the needle. And, where are we going to put the two branches of this reciprocal function? Well, I think what we talked about in class is once you know where this center point is shifted to, we're going to go 1 point to the left, and 1 point to the right, and 1 input to the left, and kind of see what happens to find a reference point. So that's what I'm going to do here. I'm going to put, I know that this is centered at -2, so I'm going to take -1 and put that into the function. So f of -1 is going to be 1 over -1 plus 2. That's 1 over 1, so 1. So when I put a -1 in, I'm going to get this input there, or output, I'm sorry. I'm going to get that output, and then I'm going to step 1 to the left, put -3 in there. So f of -3 equals 1 over -3 plus 2 equals 1 over -1 equals -1. So when I put this input in of -3, I'm going to come down here, and that is going to help orient me that I know that my branches are going to go through those 2 points. And there's no reflection or stretch here, so I can just use that as, so this is essentially the reciprocal function shifted to the left too. If we look at cell, then I'll do C here. So here we have A is equal to -1. Now that, the top there is 1, but don't forget we see that negative sign there, so you have to make sure that that's going to show up as a reflection. This is like x plus 0 here, so the horizontal shift is 0, and the vertical shift is going to be 2. So we're going to go up 2, and nothing left to right. So what's going to happen to the asymptotes here? Well, remember the parent function asymptotes are x equals 0, y equals 0. Well, there's going to be a vertical shift up. B had a vertical shift to the left, but there's no left-right vertical shift, so this is going to be our center point now. So now we have to fit in the branches where they're going to go. Because this is a flipped function, we kind of know that they're going to show up in these quadrants here, but I want to at least get a reference point to make them a little bit more accurate. So what I'm going to do is I'm going to take my center point, go 1 to the right, 1 to the left, and use those inputs. So f of 1, which is 1 to the right, put 1 in there for x, you get -1 over 1 plus 2 is positive 1. So here, that's going to point's going to be on the graph. And if I go 1 to the left, put -1 in, you get -1 over -1 plus 2, that equals 3, because these two negatives cancel to make a positive 1. Right there. And so now we can see that this reciprocal function is going to show up in these 2 quadrants. Which makes sense because it's reflected. The typical one would have been quadrant, like this shifted quadrant 1 and shifted quadrant 2. So you can look at the answer key for the answers to the other 2, but that's basically the process. Identify A, H, and K, shift those asymptotes, find a couple points, and sketch them in. Okay, so this is just trying to put that idea of shifted rational functions in context a little bit. So we have, you're going to thank me for a great year, you're going to buy me a present that costs $300, or maybe the school is going to buy that for me. Just kidding. But we're trying to figure out what's the cost per person if everyone pitches in equally. So let's say there's N students, and we got to take that $300, and it's kind of like I've talked about the bagels and cream cheese or whatever. But this is the cream cheese, and the students are the bagels. We got to figure out how much cream cheese goes on each bagel, and that's what's going on here. So like A, we're saying C1 of N, so that's just the function name. Cost per person 1 is going to be 300 divided by those n students. That's how we divide it up equally across everybody. You can see that this is a reciprocal function that's got a 300 stretch in it. If we thought about graphing this thing, it's going to have a horizontal asymptote. Well, there's no h and k, so it would actually be at 0. So the question is, why was this graph going to approach 0 as the number of students gets really large? Well, think about if there was 1 million students, you're going to take $300 and divide it across 1 million students. That's like fractions of a penny per person. So that's why the more people you have, the smaller the per person cost gets. And that's why the asymptote does what it does. The asymptote equation is, in fact, y equals 0 because there's no shift that's occurring here. B, so now we're saying what's the cost per person, per student. Actually, this is not, it's kind of confusing here. I mean this to be cost per student. No, per person, sorry. It's the cost per person, but there's 5 teachers you're throwing into it. So, n is still the number of students, but the function is per person. So now we have 300, but now the number of people are the number of students plus those 5 teachers. And so the cost per person is going to get spread out over 5 more additional people, and so you get this function here. The idea is that this function is still going to have an asymptote at 0. It's just going to shift left a little bit because of those teachers. But that's the function there, and you can see that this is going to be a function where h is -5. A is still 300, but there's no k. And then this last function, sorry, that was a 2 up here. And then this last function, C3 of n, is going to be, everyone takes what their share of the 300 plus throws in an extra $4. So we're going to start with what we had before. We're going to divide it by the students plus 5. But now we're just going to throw $4 in for whatever reason. And now we can see that this is like a transformation where k is equal to 4, h is equal to -5, and a is 300. Here, the horizontal asymptote, because there's a vertical shift, will move up to here, y equals 4. So we'll have this thing approaching here. Well, this makes sense that since everyone's paid exactly $4, everyone's going to owe $4 plus their share of the 300. So even if that share gets super, super small, they're still going to owe a little bit more than $4, and that's why this is an asymptote, but it never goes below 4 because everyone's paying at least that $4 in this part C. And then D, use your function in C, determine the cost per person if there are 15 students and the 5 teachers. Well, C3, that just means evaluate C3 at 15. So 300 over 15 plus 5 plus 4 is going to be 300 over 20 plus 4. 300 over 20 is 15, which is $19. So if there were 15 students and everyone shares the gift plus throws $4 in, the cost per person will be 19. E, I'm going to skip. You can check the graph on the answer key, and it's very similar to what we had just done in the prior problem, except with some a little bit different numbers, especially that 300 is kind of a bigger number.